Okay, Calc 30, this is an optimization problem. This is a type that I haven't shown you in class yet, and it's an important one for you to know. So number 17 says this: find the dimensions of the rectangle of largest area. Okay, so we kind of see what we're going to have to optimize here. Rectangle of largest area that can be inscribed in a right triangle. So a right triangle is, and here's the sketch of it. Okay, there's a right triangle with legs of length 6. So there's your 6 right here, and length 8 down here on the bottom, as shown in the figure. So here's the triangle, and the area of the rectangle right here is also drawn inside the triangle. So inscribed, right here, this word inscribed means that the triangle is contained inside the rectangle in this, in the triangle in this fashion. So we have one point that's actually on the hypotenuse. So the rectangle could look something like this. Okay, that could be the rectangle, or it could be really, really short and long. Could be like that, right? So those are the types we're looking for. Now, the key to this question here, and again, you want to write an equation of, or a relation, I should say, of no more than 2 variables of what you're trying to optimize. So what are we trying to optimize? Well, largest what? Area. And largest area of what? The rectangle. So you can see, and again, if you didn't have this diagram, this is how you would sketch this up. And you're going to have to place a variable x here for one dimension and y for the other. Pretty easy. So the area is what we're trying to optimize. And that's going to be simply x times y. Okay? So again, I would always start there with the relation of the quantity that you're trying to optimize. In this case, it's area. We have 2 variables, and we don't want 2 variables. So the second part is often the toughest. What you have to do is you have to consider all the information in the question, and you have to try and find a relationship between the 2 variables. Another relationship, not the area one, but you have to try and find another relationship that you can set up as an equation that relates the 2 variables and somehow relates some of the constraints that you're given. In this case, the constraint is it has to fit inside a triangle with these dimensions. So how do x, y, and 6 and 8 relate to each other? Okay, and that's going to be the second equation. And I'll put a little divider there. And in this type of question, what you're going to want to capitalize on is the fact that the rectangle is 90-degree angles here. And if you notice this, but this large triangle, the 6x8 triangle, okay, right here, is a similar triangle to this little triangle right here and to this little bit larger triangle right here. So we have a series of similar triangles, the large one and then these 2 smaller ones. And when they're similar, it means that they're the same shape but different sizes. And it also means that the ratio of the proportions of those shapes will also be equal. Okay? They have the same proportion. So what you want to do is you want to set up a relationship that looks like this. This triangle right here, the relationship between this side and this side should be similar to the relationship between, and I'm going to pick this one, this triangle, between this side and this side. So we have a ratio that we can set up. Okay? So I'm going to go 6 over 8 equals this length right here. This is the corresponding length. And of course, this is y, and this full length is 6. So this is going to be 6 minus y. So 6 over 8 equals 6 minus y, that's this side, divided by this side. And that is going to be what? X, exactly. That's just x right there. Okay? So that's the similar triangles. And again, you haven't seen anything quite like that yet. I haven't shown you anyways. So that will come up a few times, the similar triangle thing. And I think in question 18 that's on your assignment, you're going to have to capitalize on this sort of thing as well. So I can solve for one of these variables. It doesn't matter which one. It might be easiest to solve for x here. X equals 8 times 6 minus y over 6. And so we can simplify that one. 48 minus 8y over 6. Okay, and yeah, we can simplify this. I guess I could have done this up here, right? Could have done 4 and 3. So what's that going to give us? Half everything, I guess. 24 minus 4y over 3. So that's going to be good enough. And now we can go back to our relation that we're trying to optimize, and now we can rewrite it. We can combine two equations together, can't we? So a equals, the x is actually equal to this, and we're going to write this in terms of y. So 24 minus 4y over 3 times y. Now, if you wanted to solve for y, you could. I like to solve for y and just deal with in terms of x, but you don't have to. So here, y is going to be your preferred variable. We really have a as a function of y, so we'll differentiate with respect to y here. Okay? Okay, so what I'm going to do is I'm going to give you a chance. You should be following along here. I'm going to give you a chance to take the next few steps here and see if you can work through this and get along on this, and then I'll kind of work through it a little bit later, and you can check and see how you're doing compared. But that's the tough part. That's the tough part. So we just simplify this area function, take the derivative, right? Don't forget to take the derivative. So go ahead and work on that for a few minutes. Okay, so here's just a little bit further on. Maybe you've had a chance to try this. Just doing the derivative for you here. It's going to be 1/3 times 24 minus 8y, which can be simplified. 24 over 3 is 8 minus 8 over 3y. Let's set that equal to 0 and solve for y. So we'll get negative 8y over 3. I like to put that y up in the numerator instead of having it to the side, because then there's no question where it is, up top or on the bottom or what. Okay, so that's a positive then. I'll make that a positive. So 8y equals 3 times 8, 24. Y is 3. Okay, so I get y is 3. Now that's nice, because in my diagram I have a y over here, and again that's the variable that I have in this area function. So if y is 3, I can solve for x, and this is exciting, that I have x defined over here in terms of y. So 24 minus 4 times 3 over 3. Well, that's 24 minus 12 is 12 over 3 is 4. So if y is 3, then x should be 4. So the dimensions of this rectangle with largest area, dimensions would be 3 centimeters. Is it centimeters in this question? Yep. 3 centimeters by 4 centimeters, and that is your answer. Okay, I'll just shrink that down maybe so you can see the whole question there. Anybody have any questions about that? And did you get 3 out of 4? Anybody get 3 by 4? Yeah? Maybe? Okay. Some of you are still working on it? Okay, so that's number 17 on your optimization assignment there.